Hello, welcome to this tutorial video on electronic configuration, valence and ions. So these are the topics that we are going to look at in this tutorial video. Okay, so in the previous video we talked about what an atom is. We know what makes up an atom. Okay, so one of the things that we looked at when we talked of an atom, we said an atom has three fundamental particles. We said it has protons, neutrons and electrons, and we said the protons and the neutrons are inside the nucleus, where the electrons are surrounding the atom. Now one thing you should learn is that electrons in their shells, they are at a constant speed. They are moving at a high speed, like they are rotating the nucleus. So from our previous discussion, we said we said an atom has a central part. We called it a nucleus. So let's say we have this as our nucleus. Then we said in the nucleus we have protons and electrons. Now we said electrons are found outside. So in the same way the planets orbit the sun, that's how the electrons are moving. So they will be moving in different paths, the way you don't see the earth moving in the same path with the other planets. So each planet has its own path. So even electrons have their own path which they are using to move around the nucleus. Now we called those as shells or orbitals. So this is what we are going to look at. Now what we see is that when we are talking of electronic configuration, we are trying to understand how are the electrons arranged, since we realize that electrons are constantly moving around the nucleus. But how are they arranged? Like let's say for an element with 10 electrons. So what element you guys has 10 electrons? We have elements called neon. So neon is equal to 10 electrons. So the question chemists ask themselves that of these 10 electrons for neons, how are they arranged? Okay, do we find them all the 10 electrons surrounding the nucleus in the same orbit or in the same shell, or they are of different shells? Let's say for instance maybe neon has 10 shells and each shell contains 1 electron, or maybe neon has 4 shells and each shell maybe the first shell contains 2 electrons, the other one maybe contains 4, the other one contains 4, or is it that maybe it just has 5 in each shell? So those are some of the things chemists ask themselves, and this is what we are going to write answer. Okay, so when you're talking of electronic configuration, we are simply talking of how are the electrons arranged in an atom. Okay, so this is what we have to understand, that an atom will have a nucleus and shells. It's not true that every atom has one shell. It can have many shells as possible depending on how many electrons it has, because there is a rule that is used to arrange electrons in shells. So this is how we begin. So we are going to have a shell. Let me try to make this clearer. So we have the first shell. So I'll represent the second shell in this color. Okay, then I'll represent the third shell in this color. Yeah, so I think now it becomes a bit clearer. So you can see that from the nucleus, which I've painted this color here, from this nucleus we have the first shell here, and we have the second shell here, and we have the third shell which is almost in middle. So this is the rule. The shell that is close to the nucleus, we call it the innermost shell. So I'll represent this innermost shell. I'll give it a letter L. Okay, then the shell, so letter L simply means the shell next to the nucleus. I'll name the nucleus as N. So this central part I've painted blue is the nucleus. Okay, so from the nucleus, the shell that just comes after the nucleus is shell L. The other one is shell M. The other one is shell N. So if there was a fourth shell, I'll call it shell So it's just the alphabet. L, M, N, O, P until you have Z somewhere. Okay, depending on how many electrons that particular element has. So there's no this one for naming this. We just choose the alphabet. You can choose, if you want, you can choose shell, the innermost shell to be A, meaning the other one will be B. But what you should note is that every shell has a specific number of electrons it can accommodate. So it has a specific capacity, like every shell has specific space. Now that space corresponds to how many electrons it can accommodate. So let's say, for instance, we have the first shell. So first shell is shell L. So shell L can only accommodate a maximum of 2 electrons. You guys have to understand this. When I say maximum, meaning you can't exceed 2. Even when you have 3 electrons, you can only get 2. The other 1 electron cannot be accommodated. So like the space can only allow 2 electrons. Chapter. So shell L. What is shell L? That's the innermost shell. The shell that is closest to the nucleus. So from the nucleus, the shell surrounding the nucleus, the first shell, shell L. Then we have the coming shells. Now the coming shell, the next coming shell is shell M. Shell M can accommodate a maximum of 8 electrons. Okay. From shell L, what is the next shell? So the next shell is shell N. So shell N can accommodate a maximum of 8 electrons. Imagine we had the fourth shell. We could call this fourth shell as the shell O. So how many? So imagine we have a fourth shell. So shells, imagine these are just places where you can place electrons. So shell, we can call this as shell O. Shell O can have a maximum of also 8 electrons. So this, you guys, but as you go to the college or university, you realize that this will change. But in the meantime, this is what is appropriate at high school. Okay, so what do we see? We realize that if we were to continue writing all the shells, you will realize that all the shells are just, apart from shell L, all the shells will have a maximum of 8 electrons. So what does that mean? It means that only shell L contains a maximum of 2 electrons. The remaining shells, they are filled up when they have a maximum of 8 electrons. So this is very important, because if, let's say, shell L just has 1 electron, that means shell L is not fully filled. It can only be fully filled when it has 2. The moment it has 2 electrons, if there are other remaining electrons, they will be pushed to the next shell, which is shell M. Now shell M will contain a maximum of 8 electrons. So if there are 9 electrons remaining, it can only get 8. Push the other electron to shell N, so on and so forth. So all the shells apart from shell L, they contain a maximum of 8 electrons, whereas shell L contains a maximum of 2 electrons. So the shell close to the nucleus, we call it the innermost shell. So like in this case, shell L, we call it innermost shell. It's in the like when you, it's in the shells. Then the shell which is at the end, at the last, we call this as outermost. You guys, I don't think this is a problem. Innermost inside, outermost outside. Okay, so the innermost shell, 2 electrons. All other shells, apart from the innermost shell, they contain a maximum of 8 electrons. So let's say, for instance, we want to write electronic configuration, which is just how are the electrons arranged. So it's simple. Let's pick an element. Let's say we'll begin with this element. Okay, begin with element hydrogen. So hydrogen has how many electrons? It is number 1, so it has 1 electron. So just write 1, because it can only use so this electron will only be placed in this shell. Okay, so we have helium. So helium is number 2. So helium is number 2. 2 electrons, so it will just have 2. Where are the electrons? They will just be within this first L shell, because L shell can have a maximum of 2 electrons. Suppose we have elements such as boron. Boron, you guys, is number 5, so it has 5 electrons. So this is how it is going to place them. It will place the first 2 in shell M. So this is shell L, then we have M, then we have N. So it will place the first 2 in shell L, okay. Then how many are remaining to make 5? It is 3. So to place the 3 electrons in shell M. That's all. Okay, we go to the next element. I will have to skip you guys for the sake of time. We will go to, let's say for instance, magnesium. So magnesium is represented in short form as Mg, okay, capital M and small g. So this has how many electrons? It has 12 electrons, because it has an atomic number 12. So to first place the first 2 electrons in shell L, how many are remaining? We are remaining with the 10. Can it place all the 10 in shell M? No. According to this rule, shell M can only contain a maximum of 8 electrons. So to place the other 8 in shell L, how many are remaining to make 12? We are remaining with 2. It will place the other 2 in shell N. So this will continue, like every shell has a specific number of electrons it can hold. Okay, let's also jump and go to element. Which element are we going to look at? Let's look at element chlorine. Chlorine is number 17. So in short form, we write chlorine as capital C, then small letter L. So it is number 17. So it's going to put the first one in L. It's maximum 4. It will contain 8. So this is 10. Shell N will also contain how many to make 17? So it will contain 7. Okay. So if you go to the next element, which is let's say, which is so here allow me to squeeze a certain element here. I will squeeze element number 10, neon. So neon, it will have first 2 in shell L, and because it's number 10. So here we'll also fix an element called argon. So argon is number 18. Okay, like this. So it will have 2 in L, to have 8 in M, and 8 in this one. Okay, so what do we see? When you are representing electron in such a manner, where you are saying that it's 2 commas, maybe something like this, like let's say for instance for argon is 2,8,8. This arrangement is what we call an electronic configuration. It's telling us that if this atom was for argon, let's say if this was argon, so you write the symbol of an element in the nucleus. This was argon. This is how argon will place its electron. So if we were to place argon's electrons, we would put which color can I use for electrons? Let me use this one. Okay, so it will put the first 2 here. Okay, then how many are remaining? Are remaining with the 16. So the other 16, it has to place it in. So shell M will contain a maximum of 8. How many are remaining? Are remaining with 8 to push them to shell N. So shell N will also have a maximum of 8. So this is just showing you how electron would be placed. Okay, something like this. I hope you are making sense out of this. So this is just what electronic configuration is. Now there is an aspect of stability. Okay, when you have everything, you are stable. When you don't have everything, you are not stable. How do we know whether this element is stable or not? It depends on how many electrons it has. An atom which has the required number of electrons in the required shell is called to be stable. What do we mean? An atom which will have 2 electrons in shell L, and 8 electrons in shell M, then that atom is stable. What am I trying to say? L can have a maximum of 2 electrons. So for an element which has one electron, let's say for instance hydrogen has one electron. So how is it going to put its electron? It will just put in shell L. So in shell L it will have how many electrons? Just one. Now, is shell L fully filled to its capacity? No, because the full capacity of shell L is equal to when it has about 2 electrons. So what does this mean? This means that hydrogen is not stable, because for it to be stable, it needed to have shell L filled. So let's say if an atom is occupying, let's say 3 shells, maybe shell L, M, and N, meaning for it to be full, all the shell must be filled to the capacity. Then we say that element is stable. Let's take for instance oxygen. So oxygen is represented as O. So oxygen will occupy 2 shells. It will occupy shell L and shell M. So in shell L it's going to put 2 electrons, and in shell M it's going to put 6. The question is oxygen stable? No, because quite okay, in shell L it has filled shell L to its capacity. But has it filled shell M to its capacity? No, because the full capacity of shell M is equal to how many electrons? You guys, we say M is equal to 8 electrons. But here shell M is just 6 electrons. So meaning for oxygen to be stable, how many electrons does it need? It has to gain, you have to add to it 2 electrons so that it makes 8 electrons. You have to add 2. When you add 2 electrons to it, then what are you going to obtain, you guys? 8 electrons. Then you make it stable. So the point that I'm trying to drive to you is that for an element to be stable, it needs to have, depending on how many shells it have. If it has 2 shells, then it must have 10 electrons. If it has 3 shells, it must have a maximum of 18 electrons. If it has 1 shell, it must have 2 electrons. So what do we come to realize? You realize that for helium just has 2 electrons, and it's just putting those 2 electrons in shell L, and shell L just needs 2 electrons, so it is stable. But for elements such as lithium is number 3. So lithium will put electrons like this, 2,1. This is shell M, this is L, this is shell M. So that shell L for lithium is stable, is fully filled, but is shell M fully filled? No, it is lacking 7 electrons to make this shell full. So lithium is not stable, because in the last shell is not fully filled to the kappa, so it can still marry other electrons, okay, for lack of better term. Okay, so look at neon. So neon has how many electrons? It has 10. So it puts these electrons in the first shell, which is L, fully filled, and the last shell is fully filled. So neon is stable. Look at argon. Argon is number 18. It has how many shells? 1, 2, 3. So it's L, M, N. L, yes, fully filled, M fully filled, and N fully filled. So it is stable. It does not need to marry. Imagine you're a farmer and you just have 1 cow. So for you to make a pair, you just need to add. When you have 2 cows, you are stable. But when you have 3, you are not stable, because you are going to pair the 2. What of the other one remaining? You have to still add another one. Okay. So if that's the case, so we can see from here. Now, what do we mean by valence? Valence is simply how many electrons should an element add for that shell which is lacking to be fully filled. Let's take for instance oxygen. So oxygen has this electronic configuration, which is 2,6. So the first shell is fully filled, but the last shell fully filled, no. So meaning oxygen has to add how many electrons? 2. So the number of electrons that an element is going to add so that particular shell to be fully filled is what we call valence. So valence is simply how many electrons are you going to add to make the shell which is lacking fully filled. Now the question comes, is it always to add for it to be fully filled? No. You can be stable by losing sometimes. If one thing is troubling you, lose it. So there is a rule here. Okay. So let's say, for instance, an element can. So we have, let's say for hydrogen has only one electron. So there are two things that can happen to hydrogen. Hydrogen can be safe by just losing this electron, so that it no longer have shell L. It just loses it at least. Or if it wants, it can add one electron so that the shell L is fulfilled. Then it will be stable. Or for, let's say for instance, for lithium. Lithium is number 3, you guys, like I said here. So it has to add 7 electrons for the last shell to be fulfilled. Now, is it possible to, you just have, let's say you want to buy something for 8 kwacha and you just have 1 kwacha. Is it possible for you guys to, let's say your friend has 7 kwacha and you have 1 kwacha? Which one is possible? For your friend to give you the 7 kwacha, or for you to give your friend? In reality, it's possible for you to give him because he has almost enough. So what happens for elements which have, let's say in their last shell, if the last shell needs a capacity of 8 electrons, an element can only lose up to 3 electrons. You can only lose up to 3 electrons. So those elements in which the last shell has either 1, 2, or 3 electrons, get me right here, an element in which the last shell, by last shell I'm meaning shell starting from shell M, if it has 1 or 2 or 3 electrons, then it can lose those electrons. But if the last shell has 6 or 7 5, 6 or 7 electrons, it cannot lose. You can't lose all the 5. You can just gain that which you need to make 8. So if it has 5 electrons in its last shell, it has to just gain 3 to make 8. If it has 6 electrons in that last shell, just have to gain 2 to make 8. If it has 7, just have to gain 1. So depending on which, if it has 1, 2, or 3 electrons in its last shell, that particular element is going to lose. So meaning its valence is dependent on how many electrons it gains or loses. Okay, so if an element gains 2 electrons, then its valence is 2. If it gains 3, its electrons is 3. But if it loses 2, its valence is 2. So valence is simply dependent on how many electrons can you lose, can you gain. Sometimes some elements, they don't need to lose or gain. For instance, an element which has 4 electrons in its outermost shell, so it has to gain other 4. It cannot easily lose or it cannot easily gain. They have to share them. So we'll know more about bonding where we'll explore this property. But what we should know is that valence is simply the number of electrons that you can lose, gain, or share. So if you lose 2, meaning your valence is 2. So it's just the power, the combining power, the power, like how many electrons do you need to be stable? Okay, it will depend. Do you need to lose them or do you need to gain them? But how many are you losing or gaining is simply what we are calling a valence. So let's say, for instance, we get let's get sodium. You guys, sodium is number 11. So sodium, the symbol for sodium is this. We'll learn about these symbols later. So sodium is number 11. So its electronic configuration is 2, 8, 1. Okay. So if it's number 11, we can represent sodium as this way. So meaning this 23 is let me write it in bigger terms so that you guys then. So sodium is written like this. So it has this kind of arrangement. So what does it mean? The mass number for sodium is 23 and the atomic number is 11. So sodium has 11 protons and has 11 electrons. Okay, so what is the charge for sodium atom? It's 0. I said an atom has no charge. Okay, now imagine, so what's the valence for sodium? We said if you were to put this shell there, this is shell M, so this is M and this is shell N. So shell L, yes, fully filled. Shell M, yes, fully filled, But is shell N fully filled? No, it's lacking 7 electrons. Now, can you easily gain all the 7 electrons? No. What can you do is that sodium can easily lose the outermost electron, that 1 electron in the outermost shell. So meaning the valence for sodium is equal to a positive 1. Now, why are we saying positive 1? We will know later. So sodium can easily lose 1 electron. So its combining power, which is called valence, is 1. Now this is what happens. So this was sodium. This was an atom. Now imagine sodium loses the electron. So an atom that has lost or gained an electron, it changes the name. It's no longer an atom. It becomes an ion. Simple as that. So an ion is simply an atom that has either lost or gained electrons. So let's look at how sodium ion look like. So say sodium ion will have how many? You guys will only lose electrons, not protons. So the protons will remain 11. But how many electrons will be there? They will decrease. The electron will remain to 10. So that when you sum this, what you guys do find? Positive 1. So you can say that the charge on sodium ion is positive 1. So when you lose, this is simple. If you are losing, you have a positive charge. If you are gaining, you have a negative charge. We'll know how. So let's say, for instance, magnesium. Magnesium is like Mg, 24 here, then 12. So the electron configuration for magnesium is 2, 8, 2. So fully filled, but this is not fully filled. So what can magnesium do? It can easily lose this. I said from 1, 2, 3 last electrons in the outermost shell you lose. So how will be magnesium looking? So before losing, so this one is before losing. Before losing, magnesium has 12 protons and 12 electrons, making the charge on magnesium to be 0. But after, when it's an ion, what will happen? You don't change the protons will remain the same, but the electrons will change because it's going to lose 2. So the number will reduce to 10 electrons. And what do you get, you guys? Positive. So it's like the valence is just how many you can lose, and depending on how many you have. If you have lost 2, then you become an ion with positive 2. If you have lost 3, you become an ion with positive 3. Suppose we go to oxygen. So oxygen is number 16, you guys. So this number 8. So oxygen, this is how it looks. In a normal oxygen atom, you have positive 8 protons and a negative 8 electrons, making the charge for oxygen to be 0. What of oxygen ion when it's an ion? So when it's an ion, oxygen when it's an ion, this is what we're going to happen. It will have positive 8 protons, but imagine it's gaining 2 electrons. What will happen? The electrons will increase to 10. And when you add this, you guys are going to have negative. Simple. So any atom which gains, it becomes negative ion, depending on how many it has gained. If it has gained 4, becomes negative 4 ion. If it has gained 2, negative 2 ion. That's why you realize that oxygen, when it's an ion, it has a charge of negative 2. Because of the same principle, you guys, which you have been doing. Just add before you realize that it will be 0. But if it has gained, the number of protons will remain the same, but the number of electrons will change. So just find the sum and then you'll be done. Wow, thank you guys. That's all what we had on electronic configuration, on valence and on ion. Hope you have understood this. If you have understood this and if you find this channel beneficial, please remember to like the channel, leave a comment, and most important, subscribe to the channel so that you get new updates on the new videos. I'm Sam. Thank you.